important questions and important topics. Today we are going to discuss about digital electronics. This subject is common for most of the CSC second year students, CSC and CSC allied branches. So before starting the video, if you have not subscribed to our channel, please do subscribe so that we can give you more and more informative videos like this. And also this video is made for educational purpose. The questions and important topics discussed in this video may or may not appear in the final exam because it is really hard to guess the final paper of the exams. Here we are just focusing on important questions and important topics which might help you in exam to a some extent. So coming to our first segment of this video is the syllabus. So digital electronics basically consists of like every Jntuh subject consists of 5 units. Here the first unit is Boolean algebra and logic gates. Here again you have as I said in my earlier videos, if you have not watched that, I'm telling it again that if you have this type of thing where one you have digital systems, binary systems, and the second topic is something different called Boolean algebra, one question from this topic, one question from this topic is definitely going to come in the exam. So prepare accordingly. So coming to second level or second unit, it's gate level minimization. Here you will learn about map methods, logical gate, and mapping those methods with logical gates, etc. Again, coming to the unit 3, you have combinational logics and combinational logic circuits, analysis procedure, and so and so and so and so. So unit 4 is sequential logic, where you have sequential logic circuits, flip-flops. Here mostly JK flip-flop and SR flip-flop will play a major role. And in the unit 5 you have memories and asynchronous sequential logic or asynchronous sequential logic. So here also you have a random access memory segment, and another you have you have one memory segment and you have another latch segment. So one question from memory segment and one question from latch segment is mandatory. So you just need to prepare according to it. Now what are the tips to pass? So in our second segment we'll discuss about tips to pass. So I'm saying this in my every video that prepare 3 chapters perfectly. 3 chapters in the sense not only important questions, but if a question is asked from random xyz topic, then you need to be able to answer that. So you need to be that perfect to get the pass marks. So other one is focus on short questions equally, as this helps in getting 4 to 5 marks. So short questions are really important, and your paper presentation is also important. Starting with the short questions will help you getting 4 to 5 marks, which will again help you in getting pass marks easily. 21 is your pass marks for R22, and that will be like that. And units to prepare are 1 2 3 4 5. Follow this while you start your preparation. Why I am saying here 1 2 3 4 5 is this digital electronics. If you don't understand first unit, then you will not understand second. If you don't understand second, you will not understand third, and same is for fourth and fifth. So you need to go in an order. There is no big or small unit in this. Every unit is easy, if you believe me. If every unit is easy, and also it will be helpful if you understand one unit, and the other unit is interlinked to the previous unit. So this is how it is. So now coming to the important topics from unit 1, you can check this binary numbers and binary codes. So first you need to learn that. As I said, one question from binary and another question from Boolean functions or Boolean algebras. So this is from unit 1, if you can see. And also if you want important questions, you can download exam update app, which is on Play Store. R22 R18 questions are readily available there. The detailed important questions are available on the exam update app, so you can try that. That is for free. So now coming to the important questions. So what we can expect, I think the questions are of this type, and please watch the video till the end to find the previous question paper, and we'll discuss more about that in the last segment of this video. So explain the theorems of Boolean algebra, explain BCD and XS3 and gray codes. You have again here important would be what are universal gates. You need to understand about universal NAND gate, NOR gate. So you need to understand this and prove NOR gate is a universal gate. So such kind of theory will come from this. And if there is no theory, then definitely one problem from this unit can be expected. So what is that problem? You will see at the end. In the last session we'll discuss about this also. And coming to the unit 2, important topics here is k-map, a problem associated with k-map somewhere or other. A problem associated k-map is definitely it will going to appear in this exam. And implementation of boolean function using logic gates. What are the logic gates? Like we discussed NAND, NOR in the previous unit. Again, see, these boolean functions and logic gates are again associated with the second unit. Here, implementation of boolean function and logic gates, one question is mandatory. So now coming again to important questions, unit 2. What can be important questions? Explain k maps, explain don't care map entry. So there is a map entry called don't care that you need to explain here. And simply so here I have given a simple question, so where f function is abcd and e function is 0 1 2 3 4 5 6 4 6 and 15 using k map. So just practice the problems like this, and so that you can understand what is k map. So k map, a question related to k map is going to appear in the exam. And construct a 4-bit parity generator circuit using gates. So whenever there is a thing called construct or explain like that, so you can, what you can do is you can simply learn the diagram very perfectly, draw it with a neat pencil, I mean like with pencil in the neat sketch, so that you can get marks. Again, important topics in unit 3 would be mux, demux. Mux is a multiplier, demux is a demultiplier, and 8 line multiplier to 1 line multiplier. So they again, and another important topic is serial adder, parallel adder, and also octal to binary encoder. So we have encoders, multipliers, adders here. So basically these are the functions of, one is multiplication, one is adding, one is encoding. So these are the functions, so you need to be perfect with this. So these are the important topics for unit 3. And coming to unit 3, important questions. So guys, if you feel that I'm going really fast, you can just pause this video at any point and take a screenshot, so that it will be useful for your exams. So, and also you can download exam update app, EXAMUPDT. This app is available on Play Store for free. You can download and look into more detailed questions regarding this digital electronics or whatever subjects for R22. So design octal and binary encoder, and 4 input priority encoder. And see, again encoder topic is coming in second unit, and again encoder topic is coming here again. So using a full adder, implement using multiplexer, Verilog code, 8 into 1 as we discussed, 8 into 8 multiplying structure, behavior and data flow models. So these are the important questions. Design octal to binary encoder. And from unit 4, you can expect a question from SR flip flop, JK flip flop, or else you can expect a question from register, shift registers, or ripple counters. Okay, and the important questions here are clearly explain the JK master slave flip flop. So JK flip flop or SR flip flop or RS flip flop. I think these three, any one question is compulsory. Okay, and from shift registers, how can you get explain in detail about shift registers? Give a application. You can check the fourth question, which is readily here. I have given that fourth question. Or else, what is a shift register? Draw the block diagram. So you need to explain each and everything of a shift register and how a transfer of information is done from register A to register B is done. So a question on SR flip flop is mandatory here. Okay, and these SR flip flops, they are again implementing it with the universal gate, which are non and NAND gates. So this is how the question will be. So again, important questions for unit 5 would be programmable logic array, programmable logic sequences, sequential program device. Again, sorry, programmable logic, array programming, array language. Okay, and random access memory, read only memory, that we known as RAM and ROM, and circuits with latches, design procedure of latches, and etc. So here latches is one topic, and arrays and logic sequences are another one. Memory, program memory. And coming to important questions for unit 5, so you can just check what is PAL and PLA. So these are the basic questions. So if the question paper comes a little hard, then there is a chance of asking indirect questions, which you may have to struggle, but I hope you'll do well in your exams. And also, so look at this R22 model paper, where we have added, so See, this is the questions how you will answer the 1 mark questions. You don't need to go in detail so much. Don't need to write. Show the excitation table of JK flip flop. Just draw. Just put a heading of excitation table of JK flip flop. Draw the flip flop. Leave it. Differentiate a latch and a flip flop. So you just need to write what is the difference between a latch and a flip flop. The primary difference between a latch and flip flop is so and so. Okay, differentiate between RAM and ROM. So RAM is random access memory and ROM is read-only memory. So this is just a one-word questions you can answer so that you'll get 1 mark for your 1 mark for your attempt, half mark for your attempt, 1 mark for your correct answer. So this is how you are going to do. And so again, this is for this two ways question from first unit. So here again, you just got problems, Boolean expressions, a problem from Boolean expression and two's complement, perform this operation and write truth table. This is a theory part, write a truth table of symbols of and or and not gates. This is the basic and the easiest question I have ever seen. So this is for 5 marks. And again, convert BD 98.0 AC 16 to decimal, binary and octal. So this is an hexadecimal. You need to convert into decimal, binary and octal. So this is simple. You can write a heading at heading of this, explain to decimal, again to binary and to octal. So binary decimal is 1 or 0, binary is I think 2, and octal is 8. Correct me if I'm wrong, and also let me know in the comment box which questions I need to cover more and which subjects I need to do the videos more. And again, in the second unit, as we spoke about K-map, here K-map question is given, and expression for K-map. Again, K-map, minimize the following expression using K-map. Again, simplify the Boolean and verify using K-map. So everything is associated with the K-map in the second unit. In the third unit, you can see these two questions: serial adder, parallel adder, mux, demux, 8 line into 1 line multiplexer, explain its working. And yeah, the ninth beats from fourth unit, you can just see this RS flip flop, SR flip flop, Johnson counter, and universal shift register. So one question from register, one question from flip flops. So this is how it is. And again, one question from memories, that's RAM, and one question from latch. So this is the pattern, and I hope you study well, and I wish you all the best for your exams. Thank you, and also like, share, and subscribe the video. Thank you, guys.